Jason. I feel like I'm in a place where I have enough material for 1.0, 1.1, and 1.2. I'm going to try to cover those all in one video. And if there's anything you think I am missing or need to add a pin to, change any misstatements, I would really like your feedback to help me because this is really based on my own understanding of these technologies and trying to learn a little bit more, add to it, put that content in here, and abstract kind of the deeper picture of some of these technologies to what I think Cisco would be more interested in, because I don't think that they are going to want you to learn just the minor details of every library. But anyway, with that being said, I'm going to go ahead and get started on this. So the exam material for, let's say, 1.1, which is asking to compare the data formats XML, JSON, and YAML. I have a lot of opinions about these structures, and that's probably going to come through on this. I'm, by no means want to claim that I am right, but just take the data that I have and try to form your own opinions. This is still a bit of a work in progress, so again, bear with me. As you can see, I wrote up some material that you can read through yourself. I will cover that here, but in general, so what are these formats? XML, JSON, and YAML. So it's really just a structure of data in order to store it on disk or transfer it from A to B, client server, etc., and let it be not only efficient but usable in the code. And I break down some of that criteria here, trying to understand myself, why would I use what, and why do I like this one better than the other one, because I've yet to really kind of break down and try to think about it. Anyways, you can see some references here. I did reference W3 Schools. I think they have some good explanations of these. And then as far as YAML, I don't think they have one, so I just Googled around on the YAML. And like most of us do, trying to understand some of these topics. But again, I'm just trying to abstract some of this for what I feel like will be on the exam. I came up with kind of a system of ranking these data formats. You can see that I've got some question marks in here that I haven't really fully fledged out how I want to kind of to rank those. I could come up with some numbers, but realistically, these are just numbers that I looked at from my testing to determine this. Take it with a grain of salt. The human process, right? This is what I think is kind of the overall ability to look at the structure, write it, so read and write from a human perspective, and be able to just overall comprehend that data structure without a whole lot of extra mental process or unnecessary thought that needs to go into this. Obviously, we do enough of that in our day. There's no need to add any additional workload. I like to keep things as simple as possible. And then the code usability. So once, let's just say we use these, which I should have probably referenced up here. Well, it's actually in the next section, but once we parse these data structures into our code using native parsers or maybe a parser you found on GitHub or your own parser, how usable is that data? How usable are the parsers that are available today? Does it make sense? And that's really the code usability. And then code performance. This is kind of a gray area because I'm using two native parsers in Python and one that is not native, and that's for the YAML. And the reason I say that this is a little gray is because a lot of times these functions, depending on what language they're kind of written in, will perform differently. So for instance, Python is generally pretty slow at a lot of things unless you're using a lot of the C libraries. And I didn't dig deep enough into these individual parsers to see exactly how this code was written. So my opinions are purely based on using the libraries that I'm going to be presenting. As you can see, you can look at this and like I said, take it with a grain of salt. But I'm going to move forward and kind of talk about some of these comparisons and how I did them. So what I did was I wrote a Python script, right? What better to kind of determine a comparison between these than to use them and take a look. I only ran through certain functions, but I tried to do them as efficiently as possible. Just very simple functions, not to go too deep into that process. And again, I'm not sure exactly how far Cisco's going to want to go on that. So my objective of the script, I kind of did a print statement here just to kind of cover, hey, what do I want to look at? So one was the parsing times. The next was, how large is this data set in a human readable format? If I stored it on a file in a way that I could read it natively, which really doesn't make a lot of sense anyway, because I could just store the most compressed version of that file as possible, and I could load it in code and then actually print it out in a pretty fashion to make it human readable. And then how large are the data sets when in their smallest transferable format? And what this really I was looking at is if I'm looking at the same data in different data formats, if it's not dependent on the white space to parse, if I remove the white space and I shrink this file down as much as possible, and then I also compress it, what is that size? And then if it's in bytes and I transfer that over the wire, just how much data is that to transfer over wire? How much data is that to store? So that's really what that question is about. What you can see here is I actually created 3 different data sets. I did it in XML, obviously, right? These 3 data sets that they're asking about, the formats, JSON and YAML. It's the same exact data. I just formatted it in those data formats so we could compare them. So feel free to open those up. They're actually under, if you back up here, under the exam material, it's just under data sets, right? So I'll just open one to look at. And I actually kind of just built a generic data format here that I thought would be kind of relevant to networking since we are dealing with Cisco. And I actually have written a lot of code around networking data modeling. And so that's what I did. So you'll notice if you look through these that literally the data that is in them, the way they are structured, is the same. They are just in different formats. So let me back up here. So again, we'll get back to the script. So what I did here, this is actually a C profiler in Python. And what you do, I can show the functions for running this, but all it does, if you're familiar with profilers, well, I wouldn't have to explain it if you're familiar with profilers, but we'll just assume that you're not. A profiler is just a wrapper for another piece of code, and what it does is it will break down the individual calls within that function or method and tell you how long it takes to execute each one, and then they'll have an aggregate. So if you look up here, in order to run this particular call, which let's see, this was, there we go. Okay, so this was the XML. What I did was I actually iterated over the just the loading, the parsing of the file using the parser 1,000 times, right? And just to kind of try to average and remove any anomalies and give us an idea of the comparison more accurately from a percentage perspective, right? I mean, obviously, if you ran this once and you parsed it, you need to really divide that by 1,000. You can see XML, 0.032 seconds, right? So that's 32 microseconds, and to run 1,000 iterations of this parse. And then down here, this is the JSON, which you can see is about 3 times faster to parse the same data. Again, running 1,000 iterations. Down here is the YAML, and I really don't know why this takes so long. I do know that this is using PyYAML, and I was just assuming that a lot of this code is probably written in native Python, and that might be the issue. Python, at its core, underneath, it's actually C, right? And so if you can rewrite a lot of your functions in C, import those, and then kind of script over those C functions, things tend to get much faster, especially if it's, in most cases they're already in C if it's a native library, at least parts of it. So you can see this is 6.327 seconds, and my question around this is, why does that take so long, right? I really don't know the answer to this. I have some guesses. My main guess is just the fact that if you look at the data structure, and this is just going to be a coding kind of thought here. If you look at the data structure, it's very simple. It's extremely readable. The issue is there's not a lot of kind of a static way of determining what is what, and so Python by default does what's called duck typing, and it will take a value for what it is and kind of make an assumption of what that is. And I'll give you an example. So for instance, you look at this, it's got alphanumeric characters in it, right? Well, we can assume that's not an integer, it's not a float, it's probably a string, right? And so Python is going to look at that and kind of determine what it thinks that's going to be. And I can assure you that if you just put this in the way, well, you would have to quote it, but ultimately you would not define this. You would quote it and it would become a string. But what I'm trying to get at is that none of this is really statically defined. The one thing you can kind of look at here that is indicative of structure for, let's say, a list of some sort or etc. is just kind of the hierarchical design of it, right? But outside of that, it's a really small file. There's not a lot in here to kind of, if I were to write this parser, it would probably take me quite a bit of code just to try to figure out what all of this is, even though reading it seems to be very simple. That's my thought on that, and I will back up and get back on track here. So where were we? So anyways, you can see parsing of the YAML is very slow. And then in the script, what I did was, I basically took these in different types, what I would consider, let's say, as a string. So this would be the kind of native file. I would just import that, open it up, and take it as it is. It's going to have all the white space in it, etc., which is just extra data if I need to store it or transfer it. So you can see that one's generally, well, in every case, is going to be the largest. And then if the data set doesn't require, or the data format doesn't require white space to indicate what it is, I remove it, right? Removing it and then having to read it would be really hard to do. You could do it, but it would be really hard to do, so it doesn't make sense from a readable perspective, but it does make sense from a code perspective. And so you can see there is the no white space. And then here is the bytes version of that with no white space. And there are kind of very small changes in the no white space whenever you move it from bytes or from string to bytes and vice versa. They're very small differences, and to be honest with you, I really don't know what those are off the top of my head. I would have to pull up Google to look, but I do know that there are some minor differences. And for it'll mark it as bytes, which is like a B at the beginning or whatever. And then there are some ways the encoding is ever so slightly changed. But then what I did here is, of course, if I was going to transfer it or store it, I may gzip it, do whatever compression I can on it, which you can see at that point. That's where we get what I would consider kind of the usable size. Of course, obviously, compression requires extra cycles on your code, so you may not want to do that. And if you've got bandwidth to spare, hey, send it without the white space, and just let the processors rest easy. So I did that for all three types. So you got XML, you got the JSON here, and then you get down here to the YAML. I did not remove the white space just because it's required for the structure of the data format. And then disclaimer, right? Basically saying, I'm not real sure why this is slower, but I wouldn't use it because it's super slow. And that goes back to my original kind of opinions about it. So what I'll do here is I'll go up here and we will go over the data structures code file that I made to do this. Let's see here. So what I did, and this is just kind of the only real reason I put this in an object is I just felt like it was just more organized at the end of the day, and I thought I was going to possibly reuse this code. But with that said, I will talk about this. So here we go. So data structures. Let me see here. So what I did is I opened up these files. Now there's multiple ways to skin this cat. This was just a way that whenever I was doing it made sense at the time. I was going to use these files from different folder locations, and so this is why I did this portion right here, if you're wondering. But I will skip over that, and then obviously I printed out my objectives, and then wanted to print the file names so we understand where those are. This in section piece here is just a function that I created, so whenever the script ran, it would basically do an input statement and allow you to kind of stop like a more function, right? And that way you can just hit enter, that's exactly what it does. If I can get down here in section, so input precedent key, enter, and then the self clear is just more or less say check if it's Windows or Linux and do the system command to clear the buffer on your terminal. Here I created a list of results that I could store in, right? Depending on what I wanted to do with it after the fact. But with that results list, I created three different. I have to check myself here. Process XML file. I don't know why I camel cased that, but anyways, regardless, what I did was I created three different methods. By the way, method is just a word for a function inside of a class, in case you didn't know. And what I did was I took the return of those functions and appended it to this list, right? So then I'll end up with an array of three different results. First one being XML, JSON, then YAML. And this is where I printed out some of those results after I got them. So then I got the results, and then basically I went through the result data set and printed those out. Here's the function for the gzip, to zip it and decode it. And this was actually pretty simple. All I was doing is using those parsers, importing the data into that parser, which you could consider as it being parsed to the object. And that's where I got my timings. I wanted to know, how long does it take for this data set to become an object that has been parsed in Python. And then, let's see here, to process the file, you would think I would have gone over this prior to the video, but let's see here. So we open the file and then we read it, which basically just takes the file object and it has its own function written inside that object. It's a read function and it just returns a string. So at this point I have, for instance, the XML file output as string. Then I create a dictionary here of the XML results. And let's see, this was me, I believe, just removing white space. This was my quick and dirty, get rid of the white space in that string. And then what I do here is I take the function from the XML tree, which is available in the Python native libraries, and then I take the string, XML string, and create a, well, it returns a root object for XML. And right here, I take that root object, I send it into a function that is also in XML that converts this into a bytes object. So all of this, I'm just using functions that are available, and you can look up these functions in this XML tree. By the way, it's right here. I put it at the top of this file. It's also referenced in the README. You can go here and it shows you all of the functions inside of here. So that's literally what I used. I went straight here and said, hey, how do I load this? And you know, how do I parse it, etc. Which, you know, in most cases you're going to be referencing anyways. You know, I don't know what person that can remember every function and every, you know, library there is. It just gets really hard over time. I mean, obviously a lot of repetition, you remember a lot of the ones you commonly use, but coding is just a process of just kind of knowing where to look, and then obviously comprehending it. So at that point, I've got the bytes object. I also I zip it up, and then this is what I used, I believe. You know, yeah. So then I just take the exact same kind of, let's say these are dictionaries. I don't think I made these kind of like JSON, did I? No. So these are just individual dictionary. Oh well, yeah, it's obviously it is JSON because I basically have a dictionary with objects that have dictionaries inside of them and multiple hierarchical. We can go over that after this, but so I've got a key value in my XML results, key value of XML, a string, human readable, and then I created a dictionary with, you know, the description, the type. I had a string representation. It was just a lot of output that kind of dirtied up what we were trying to look at. The length of the file, which really doesn't matter in this particular case. I was just curious how that looked. And then the size of that particular string. So this is actually a string function, checking the size of that string. There's, I believe, well, it is not here because I already converted it to bytes, but there's another function that you can use to look at a string as if it were bytes. I think it's something, yeah, again, it goes back to the, I can't remember everything, right? So, and did the same thing. So no white space, no white space, no white space, gzipped, and then I returned those results. And that's what you see up here, right? So if I run this XML, that's what happened. I ran this XML, it returned the results and stored them inside of this list. And then I did the exact same thing for JSON and YAML. The same idea was to load these up, put them in different data types, and take a look at them so we could compare them. And again, I will go back and show where that kind of is. Yeah, so this is really, you know, at a high level, all we're doing here is using these libraries to load the data, the example data sets, and then convert them into these different types. We'll say string human readable, string no white space, bytes no white space, and then string no white space, and then gzip compressed. And we could take all of those types and set them next to each other with it being XML, JSON, and YAML, and try to take a look at them, see what we think, right? So this is just my attempt to encode, try to understand why I would use, any of these types. I will say some things to kind of note here. XML is old. I think it was like 99 or something like that. I could be wrong. You might want to Google that. And really, XML has stood the test of time. It's really good from just a support perspective. If you look in code, it's highly supported in like anything you want to use. You start, just pulling up different code types, something you may not know or whatever, and say, hey, how do I do this with XML? There's a good chance there's something probably there. At this point, there's, the same really goes for JSON. It's been around a long time at this point. But XML is just it's old. It's done its job. It really does pretty much everything you'd want it to do. I personally prefer JSON just because the data representation is the same in code as it is in the structure, and so it's just really easy for me to understand, and I don't have to remember anything extra. With all that being said, you can look through this file. You can see how things were loaded. I probably need to go back through here and add some additional comments, and so when you're looking through this, it will make more sense. And I will try to do that. And then, the casual, kind of Pythonic way of saying, hey, if you just launch this script, by itself, what do you want it to do? And this literally just says, if I launch it and then the name's equal to main, then go in here and instantiate this object, which is data structures, which will then kick off this data in it and do all of this fun stuff right here, which is all referenced. Oops, that's far too long. But anyways, I will back up and let's see, data structures. I think I've covered everything here, and the output of that script that I just showed you, this is the entire output when running that from my machine. You are more than welcome to run that yourself and get some output. And I will say, if there's some sort of data structure you want to do a comparison on the way I did it, you can just go in and into these, well, you could change the code obviously, but I think the easiest thing to do is to just go into these data sets and just write your own, right? Once you've learned enough about these data sets, there might be something in particular you want to know. Hey, is this faster? Is this bigger? What's the differences here? And kind of build out that structure and put it in these 3 different formats, and then run the script again. It will give you data based on that. And I was planning on doing sections 1.1 through 1.3 in this video. I think this video is running a little long, so what I'm going to do is I'm going to go ahead and stop the video, and I will make another video about 1.2 and 1.3. There wasn't a whole lot that I could find on 1.3 as far as content, so I will probably put those 2 together. So anyway, thanks for joining, and we will continue in our next video.